Let's solve this system of equations by the substitution method. First thing we must do is solve for a specific letter in either one of the original equations. Neither one of these are solved for x or y. Therefore, we must pick an x or a y that we want to solve for. As in the previous example, my recommendation to you is to choose the one that has a 1 in front of it. Now, you may not always have one that has a 1 in front of it. And if you don't, therefore, you just have to pick one of them and solve for it. You may end up with fractions, and that's okay. You'll just have to work through it. But always, if you have one that has a 1 in front of it, that's the one you want to pick. That's the best route to take. So looking at my problem, this x has a 2, this x has a 3, this y has a 5, this y has a 1. So let's solve for this y in the second equation. So I'm going to take the second equation, 3x minus y equals to 11, and solve for y. So to do that, let's subtract 3x from both sides. The 3x's cancel. I end up with negative y equals to negative 3x plus 11. Now I need a positive 1y, so let's divide everything through by negative 1. Solve for positive y. So I have y equals to 3x minus 11. So that's what y is in the second equation. Next step in solving by the substitution method, take what y is, what we solved and found y to be, and plug it into y in the other equation. So taking this other equation, I have 2x plus 5 times what is y in, what did we find y to be? 3x minus 11 equals to negative 4. So we took what y was in our equation after we divided everything through by negative. We found y to equal to 3x minus 11. We take what y is in the second equation and plug it back into y in the first equation. And that's what I've done here. Now the only variable I have is x. So let's solve for x. Begin by distributing. You have 2x plus 5 times 3x is 15x. 5 times negative 11 is negative 55 equals to negative 4. Well, 2x plus 15x is 17x minus 55 equals to negative 4. Continue working. Let's add 55 to both sides. Adding 55 to both sides, solving for x. I have 17x equals to negative 4 plus 55 is 51. Next, divide both sides by 17. If you punch in your calculator 51 divided by 17, you find x to equal to 3. Remember, your final answer is an ordered pair. It's an x and a y value. We have found x to be 3. We're trying to find out where these two lines touch. That is the solution to this system of equations. Well, we found x to be 3. To find y, we must go back and plug in x is 3 back into either one of the original problems. I'm going to plug it into the first one. 2 times, we found x to be 3 plus 5y equals to negative 4. Plugging in 3 back into the original problem. So I have 2 times 3 is 6 plus 5y equals to negative 4. Continue solving. Subtract 6 from both sides. I have 5y equals to negative 4, and negative 6 is negative 10. Divide both sides by 5. We found y to equal to negative 2. So our y value of our final answer is negative 2. So this is my answer to this problem, 3, negative 2. This is the point where the two lines touch. To check it, let's go back and substitute both of these letters, x and y, into the original problems, both of the original linear equations, and see if the left side equals the right side. So I have the point 3, negative 2 that I'm going to be testing. And I'm going to substitute it back into the original two equations. So I have 2 times x is 3, plus 5 times negative 2 is y. Does that equal to negative 4? Well, 2 times 3 is 6, plus 5 times negative 2 is negative 10. is 6 plus negative 10. Does that give you negative 4? Yes, the left side does equal to the right side. So this point is a solution to the first line. Now plugging in the same ordered pair, the x and the y, into the second line. I have 3 times 3 minus y is negative 2 equals to 11. So this is 3 times 3 is 9 minus negative 2, that's plus 2, equals to 11. Does 11 equal to 11? Yes. Therefore, my answer does satisfy the original two linear equations. So therefore, my final answer to this problem is positive 3 and negative 2. It is an ordered pair. It is an actual point. It is the point where the two lines intersect, where the two lines touch.